Okay guys, this is another video in solving systems of equations. So reminder, we are dealing with TEKS A.8, and it says the student formulates the system of linear equations from problem situations, uses a variety of methods to solve them, and analyzes the solution in terms of the situation. In this particular video, we are going to be solving the systems of equation using elimination, which is a new method for most of you within terms of addition and subtraction. So right now you guys do not have a fill in the blank notes to go with this. This is your own notes to do. So what you're going to have to do is write down what you choose. If you do the best writing down that you can and want to come trade, I will give you a printout of notes. So just make sure to attempt to take the notes. So far we have solved systems of equation using graphing and substitution. These notes are showing you how to solve algebraically using elimination in regards to addition and subtraction. Elimination is the easiest to use when both of the equations are in standard form. So when we have both of our equations in slope-intercept form, the y equals mx plus b, we want to use graphing. And when we have it already solved for one equation but not the other, that's when we use substitution. So this is a different method when they are both in standard form. So the first step is to make sure that the equations are in standard form. That's where you have some number in front of x plus some number in y equals some number, or otherwise known as ax plus by equals c. And we want to determine which variable to eliminate, which may be challenging for some of you, but what we want to do is look and see if any of our variables have the same coefficient, meaning the same number in front of the variable. And then what we're going to do is we're going to decide if we want to add or subtract the equations to solve for the remaining variable. I did touch base with some of you, and when I touched base with you, I told you these steps will make a lot more sense as we proceed through the examples. So the fourth thing that we want to do is plug whatever answer we get back in to find the other variable. We want to substitute and return it into the equation. Last but not least, which is something we've kind of been slacking on because we're just assuming that our math is really good, but we always need to check our solution. We want to plug both ordered pairs into both equations and make sure that it is a true system of equations. So let's go ahead and jump right into an example. Put the equations in standard form. Looky for us, they are already there. We have a xy number, so we are ready to go. Reminder guys, if you need to pause, please pause the video and take the notes as you choose. Next, we want to determine which variable to eliminate. So if you look at these, we want to look and see which ones have the same coefficient or the same number in front of them. When we look at x, we have the top equation with 1 and the bottom equation with 3. Those are not the same numbers. When we look at y, we have a y with 1 and a y with a -1. So realistically speaking, those are the same numbers. So we want to consider eliminating our y's. They have the same coefficient. And we have to decide if we're going to add or subtract the equations. To do this, we want to determine what will actually eliminate the variables. To eliminate y, we are going to add them. So we're just setting this up like a basic addition. So we'll have x plus y equals 5 plus 3x minus y equals 7. After eliminating our y, we will be left with 4x equals 12. We added our x's. We have one up here. 1x plus 3x equals 4. These would actually equal 0, which is a placeholder and is not necessary. And then we have 5 plus 7, which equals 12. Now this is back to the way, oh, sorry, I skipped a slide there. This is back to what we've done before. We know how to solve for one variable. This says 4 times what equals 12. Refreshing on our basic multiplication, we can determine that it is 3. If we do not know, we can always divide both sides by the number in front of x, which means we would divide by 4. So now what we want to do is pick any equation. For this example, I have one equation that I'm going to use, but if you like one equation over the other, if you feel more comfortable with it, you can plug it back into whichever one you choose. So I'm plugging my x back into the first equation, we have x plus y equals 5. On the last slide we solved for x equals 3. So now we have 3 plus what equals 5. We can solve by using our knowledge of math, or we can undo the addition and we could have subtracted 3 from 5. Either way, we'll get y equals 2. Now we want to plug that ordered pair back into our equations. 3 plus 2 does equal 5. 3 times 3 is 9, minus 2 is 7, so we are ready to go. The solution is 3, 2. So if you were solving this using substitution or even graphing, do you believe that you would get the same solution? So here's another example for you. We want to put them in standard form. Lucky for us, they already are. The next thing, we want to determine which variable to eliminate. Well, the x's have the same coefficient, so that's a good place to start. And we want to determine if we want to add or subtract the equations. Subtracting is what will eliminate the x's. If we would have added, it wouldn't have eliminated anything. So if we subtract, we'll get 3y equals 9. So we always have to remember to pay attention to our minus a negative. So when we minus a negative, that changes to addition. So we have y minus negative 2, which would give us a positive 3y. And the same goes for, sorry guys, the same goes for over here. We'll have 7 minus a negative 2, which would give us a positive 9, resulting in y equals 3. Plugging it back in, we have 4x plus y equals 7, or 4 times some number plus 3 equals 7. So 4 times what equals 4? X equals 1. Plugging it back in to check our solution, we have 4 times 1 plus 3 equals 7, and that is true. 4 times 1 minus 2 times 3 is equal to negative 2, which is true. Thus, we do have a solution to the system of equations using elimination. So now I want you guys to take a moment and I want you to answer the following question. Which step would eliminate a variable? First, isolate y in the first equation. 2, add the equations. Or 3, subtract the equations. 4, multiply the first equation by negative 4. I want you to think about that and write it down on some sort of piece of paper. On the bottom of your notes would be great. And be prepared for me to check your answer on Monday.